Yes, hello. Yes, we welcome you back to PSSB, Physical Sciences and Silver Bullet. The voice is Richard. Yeah, we will not get tired of reminding you to subscribe and also to comment and to like. Yes. Okay, today we are having this question. It comes from the topic electrodynamics. We have the setup here. It says consider the diagram below. We're having this setup. We are having this one permanent magnet. Between the permanent magnet, we're having the coil attached to commutators, which are pressed on the carbon brushes. And then we are having a battery here. And the question comes, the first question. It says, give the name of the device. Okay. How do we start with this one? We are supposed to use these features which we are having here to assess the type of the device. Okay, when you look at this device, we are having commutators or split rings here. So with these ones, now we can identify that the device is a DC. DC what? Okay, to complete that statement, you come and look at our battery here. Yes, the presence of the battery confirms that we are dealing with a motor. So the device is a DC motor because it has split rings and it has the battery. Okay. Then comes another question here. The question says, give a reason for your answer to 1.1 above. So in 1.1, we said it is a DC motor. Why? That's what the question wants. Why do we say it's a DC motor? This question, we answered it already. It's a DC because it has split rings, and it is a motor because we're having a battery here. We must not forget that a motor changes electrical energy to mechanical energy. So those are the two answers we have here. It has split rings and it has a battery. So after that, then comes this question. It says, name the principle on which the device above works. So after identifying that we are dealing with a motor, now the question is, motors work basing on which principle? Okay, the principle on which motors work is called motor effect. It states that if you have a conductor which is carrying electricity and that conductor is placed in the magnetic field, the conductor experiences a force. So in other words, when you place a current carrying conductor in magnetic field, it must experience a force. That force is what results into rotations. So that's it. The principle is motor effect. So motor effect, then we go to the next question. Yeah, then comes this question. It says, state the energy conversion which takes place in the device above. So we said the device is a motor by the virtue of having a battery here. So what actually happens inside this device is this, that the chemical energy changes into electrical energy. I mean chemical energy inside the battery changes into electrical energy. Then electrical energy passes through the wires, and when the wires are in the magnetic field, they experience a force. So from that description, what do we see? The change is from electrical to rotation. Rotation is a mechanical energy, or you can say kinetic energy. So the answer is electrical to mechanical or electrical to kinetic energy. Okay. Yes, then comes this question 1.5. It says, basing on the diagram, state the direction in which the coil rotates. In which the coil rotates. Okay. So to answer this question, you need to know the device you are dealing with. The device is a motor, and for motor to predict the direction, we use Fleming's left-hand rule. So in the Fleming's left-hand rule, we have the three fingers, as we can see them here. We have this thumb representing motion. We have this first finger representing field, and you have this second finger representing current. So what we normally do, you come to the setup. So now that the battery has been given, you have to know that for the battery, this side is our positive and this side is our negative. Okay. And you have to remember that these derivations were made using conventional current. Conventional current flows from positive side. So on this branch, it will be moving up, and on this branch, it will be moving down. So here we have it moving up. We have this one moving up and this one moving down. So there we come with our fingers. I repeat, thumb is motion, which we are finding out. It's the one we don't know. The first finger is field, which we know. The field is from north to south. So I'm putting my finger like this. It's from north to south. And the current, so you put your finger on the side. So the side which is easily predictable with this finger is this side. Oh, what do we see? My current is going up and my field is correct from north to south, and this is the motion which I'm trying to predict. So from that, what do we notice? We notice that this side is going up and this side is going down. So remember, we predicted only this side, and the two sides must be in opposite direction. When this one goes up, the other one goes down. So when you look at this direction, what direction is this one? It is clockwise. So the answer is clockwise. So after that, after realizing that it's clockwise, then we got the next question. So after that, we are going to go to part 2 of this very question, which is going to be in the next video. Don't forget to subscribe and also to comment and to advise. So let's take you to part 2.